Hello, in this video, we will learn how to answer questions that are asked on recursion. Now, whenever I ask any of my students what is recursion, they are able to answer any theory question on it very well. But when they are given a question to trace a recursive method and answer questions on how many times loop is executed, it feels like a maze and they do not know how to solve it. So in this video, I'm going to focus on how you should approach such questions on recursion. Let's quickly cover the basics first for folks who are new to recursion. The first question is, what is recursion? A recursive function is a function which calls itself. It is also called as divide and conquer approach as you progressively break the problem into smaller problems. For example, this function prints the number passed and then decrements it and then calls itself again. Means it again prints the number, then decrements it and call itself again and so on. This function is a recursive function. If you try running this function, you will see it goes into infinite recursive loop. Now you have been using iterative statements such as for or while. We can actually write them using recursion and vice versa. All recursive functions share a common structure made up of two parts, base case and recursive case. As we are calling function within the function, base case is what helps it to return and prevent it from going into infinite loop. Your function needs to define an exit condition from the function to prevent going into infinite loop. So typically you will see recursive function have some kind of check condition. Means you will see a if somewhere which says if some condition is true, return or do anything except calling yourself again. The else part of this if or code below if is the recursive case. This is where the function calls itself again. Here it is important for the recursive step to transform the problem instance into something smaller, otherwise the recursion may never end. Every recursive step shrinks the problem till you reach the base case. So if I take the first question again and add the missing base case, this will now print the numbers till it reaches 0 and then stop. So step 1 for you when you see a recursive question is to mark the base case and recursive case. The second thing you need to trace recursion is to see what type of recursion it is. Based upon the type, you will approach the problem. Recursion is of two types. First is direct recursion, which is where function calls itself from within itself, like our example of print me. The second type is indirect recursion, where more than one function call one another mutually. Like in this example, here we have print me which calls skip me and skip me calls print me, so together they are in recursive loop. Now direct recursion is of four types. First is tail recursion. If the recursion call is the last statement in the function, then it is called as tail recursion. The example of tail recursion is as shown. Second type is head recursion. If the recursive call is the first statement in the function, then it's known as head recursion. Like in this example, we are calling print me before the print statement. Hence it is head recursion. Third type is tree recursion. If a recursive function calls itself for more than one time, then it is known as tree recursion. For example, in this program, print me is called twice, so it is tree recursion. If there are two calls, then it is also called as binary recursion. Fourth type is nested recursion, that is recursion inside recursion. In this, a recursive function will pass the parameter as a recursive call. So when you are given a question, first two things you need to do is identify the base case and type of recursion. Now you could be asked any kind of question, like what value will the recursive function return with different input values, or how many times the recursive function is called, or what does this recursive function do, or fill some missing parts of the question to make the program complete, and many more. Now we are going to take different types of questions and go over the approach used to solve them. Let's start with an easy one first. The question is, what would simply 4 return and what does this program do? When we look at this question, we can identify the base case and we can also see this is tail recursive program. To solve a tail recursive program, we use a step or stack call method to solve it. It is like you are moving down floors from the top of the building. The number of floors you step down, you have to go back the same number of floors up to get your answer. Let's see how we will solve it. We start with simply 4, which is given in the question. We go down to the recursive case and substitute the value of n. So it becomes simply 3 multiplied by 4. We then step into simply 3 and we go to the recursive case and substitute the value of n here again. It is simply 2 multiplied by 3. Then we step into simply 2. We substitute the value of n and it is simply 1 multiplied by 2. We again step into simply 1, which gives us simply 0 multiplied by 1. Now when we step into simply 0, we know this is our base case where simply does not call itself anymore. So we start returning from our function here. Note we go the same steps backward and just substitute the return value every time. Simply 0 returned 1, so simply 1 will return 1 multiplied by 1, which is 1 only. Simply 2 will return 1 multiplied by 2, which is 2, and in next step up it will get multiplied by 3, which is 6. Simply 3 will return 6 and then it will get multiplied by 4, which will be returned as answer back. All tail recursive program need to be solved like this. Now it returns 24, and how many times simply is called? You can count it over here and it is called 5 times. And what is the program doing? You guessed it right, it is the factorial program. Now what if there were some code statements before the tail recursive call? Let's take another question here. It has a print statement and then the recursive call. I have taken program with only one statement, but there could be more statements before the recursive call. How do we solve it? The method still remains the same, step or stack call. You step in or stack the recursive function, but you go ahead and execute all the statements before it. In this question, we start with Rev 468 as given in the question. Now all the steps we have above the recursive function, we write it on the right side and we go ahead and execute it. We have a print statement, so we print 8, which is the remainder on dividing the number by 10. We then step into R by 10, which is Rev 46. Again inside Rev 46, we execute all statements above tail recursion on the right hand side. So for the print statement, we print 6. The output is now 8 and 6. We step into Rev 46 divided by 10, which is 4 now. Again we execute print of 4% 10 on right side and the output we have is 864. At this point, we have reached our base case and we start returning. Since the function is void, we just return back without doing anything and we already have our output, which is 864. And what does this program do? It prints the reverse of the number given. Next we will see examples on how to solve head recursion program. Let's take an easy question here. Question is, what will the following code return if simply 10 is called? and how many times simply is called including the first call to simply 10. So the first step you do is identify the base case. Here the return on n is equal to 0 is our base case. Next we identify this as head recursion, as recursive call is the first statement of the recursive block and there is more code to be executed after it. This kind of program is solved using step or stack call plus code method. What is this method? Let's learn it now. Now before I explain the method, I want you to understand that we are doing rough working here on the side to get the answer as per the question. Many times in exam, they will give you long function names. It's okay to shorten them and then do your rough work as it will save you time. Also some long statements like system.out.print can be shortened to SOP or just print for your rough work. So I'm going to just use S for my function name and print for printing. Let's get started. You already know the step method, so when the function simply10 is called, it means we step into it. But moment we step into it, it is calling itself. What would happen to the code which is to be executed below? What we do is keep that code ready, but we put it too in the stack. We just have one statement after recursive call, so we will put that. If we have two statements, put both. So we create stack and we park the execution statements there. Now we step into simply 10 divided by 2, which is 5. Again what we do is execute the statements after recursion, but we stack it. We then step into simply 5 by 2, which due to integer division is 2. Again what we do is stack execution of later statements of print 2%2 and step into simply 2 divided by 2, which is simply 1. We again stack the executed statements after the recursive call, which is print 1%2 and enter simply 1 divided by 2, which is simply 0. Now we have entered the base case and program returns at this point. Now when we return or step up, we pull out the execution statements from our stack in last in first out format. So first we execute print 1, then print 0, and then print 1, and then print 0. So the answer to this is 1010, and you have guessed it right, this program does decimal to binary conversion. Let's do another question on head recursion. The question is, what does this code do? Now here there are no data values given to start with. Some hint is there from the multiple choice answers. Many times it's wise to look at answers and you can eliminate a few options by just basic study of them and save yourself time in the exam. Like from these answers, I can make out that it's returning either largest or smallest value and maybe or maybe not changing the table A itself. If I look at the code a bit more closely, I see it takes an array and a number n. N seems to be used as index, so definitely linked to size of the array. We can also identify the base case. I see the function is returning array values, but I do not see any place where A is on left side of the assignment. So it is very clear A values are not changing. So option C and D are out of question. That means we are left with A or B, either it is the largest or smallest number in the array. This greater than sign actually offers more clues, but for the moment, let's assume we don't know what this code is doing, so we need to test it and find out. We have already done our first two basic steps. We marked the base case and we identified this as head recursion. Now here there are no values also given to test it out. So you have to give your own values and figure out. Now when you look at the code, you see every time n is decrementing till it reaches 1. So first thing is, when you are trying out a code, don't take a too big value of n or too small a value of n. In first case, you will lose too much of exam time, and in second case, you might not reach a clear conclusion on what the code is doing. 4 to 5 recursive steps are good enough to try out a code. So let's say if we take n as 5, since it is decrementing by 1 until base case which is 1, so the loop will be executed 5 times, which is good enough. Now what about the array? A little more analysis of the code shows when n is 1, it is returning A0, and when n is 5, in recursive case, it is using A4. So looks like n is nothing but a dot length. So we will just use a random array of int with 5 values. So we start solving this by calling simply with array a and 5. We step in and first call itself is the recursive call, which is x is equal to simply a comma 4. Here we do not have value of x, but we go ahead and substitute the values we have, and I am just writing shorter version of if here, which is a4 or 20 greater than x, then return 20, otherwise x. Now some of you who are little bit ahead and are solving by elimination would look at this statement and say, it's returning the largest number, so option A is correct, and solve the question. For some others who would still like to validate and double check the answer, we will continue solving this till we get the answer. We step in simply A3 and it first calls x is equal to simply A2. In the stack, we put in a pre-filled condition which is A3 or 50 greater than x. If yes, return 50, otherwise we return x. Then we step into simply A2. We again put in the pre-filled condition and then step into simply A1. Here we reach our base case and it returns A0, which is 10. Now when we return or step up, we pull out the execution statements from our stack in last in first out format. So first we substitute this 10 as value of x and we get 40 as return value. We move next step and substitute 40 as the value and we get 60 as the value of x. In next step up, we substitute value of 60 and get 60 as the value of x. Again one level up and we get 60. So the final answer returned is 60, which is the greatest value, and we see A is unchanged. So option 1 is the right answer over here. So this is how you solve any head recursion problem. Next we will see how to solve any tree recursion problem. Here the question is for simply 5, what will the program return and how many times simply is being called, including the original call. Now here we have two base case conditions and it has two calls to itself, so it is a binary tree recursion. How do we solve it? We solve it by creating a tree. I am using S5 to refer to the recursive function and I start this time by writing it in the center. What we will do next is step in S5 and it calls snum-1, which is 4, plus snum-2, which is 3. We step into S4, which calls S3 plus S2. Similarly, S3 steps into S2 plus S1. We continue stepping into each of them till we reach our base case. The base case are leaf nodes of our tree. Once we have reached the base case for all recursive functions, you can quickly count the functions and answer one part of the question, which is that simply is called 15 times. If you have multiple choice question, you can do one level of elimination with this itself. Next, how do we get our return value? We step up and substitute the values starting from the leaf nodes or bottom up and add them at each step. So we substitute value of S1 and S0 here and we get 1. Next we substitute the values of S2 and S1 and we get 2. and so on. We step up to substitute all the values till we reach the top, which gives us answer of 5. Let's solve another problem like this, but where the two recursive functions are two different statements. Like for example here, the question is for simply 3. What will the program print and how many times simply is being called, including the original call. Here we know our base case is when n is equal to 0, when our program will do nothing, and this is a tree recursion. So here again we will create a tree, but here we will create a horizontal tree. You can still create vertical one, but a horizontal one is just more intuitive. Again I am using S instead of simply for my rough work. Now here what we will do is start from S3 and then we will write in sequence the 3 statements, which is S2, print 3 and S2. When you are doing on paper, do make sure you leave a lot of space in between, as you know this tree is going to grow. Next we step into S2, which will again give us 3 statements above, and similar step in below will give us 3 statements. We then step into S1, which again gives us 3 statements. Here we reach S0, which we know is our base case and will do nothing. A quick count of all S will give us how many times simply function is called. Now to get the output, you start executing the print statements from top to bottom, or it is right to left traversal. Make sure you traverse the tree properly and do not miss any of the print statements. Here you will get your output, which is 1 2 1 3 1 2 1. Next let us see nested recursion. What will be the return value of a2, 1 and how many times a function is called? Now nested recursion is most complex and Ackermann function is the most common. It grows very quickly, so if you see number of recursion steps for just values less than 3, it is very high, so you might get this with very low values just to see if you understand how to solve it. The value it returns is also straightforward, and sometimes it is easier to know typical values so that you can maybe just reach the answer by elimination rather than wasting time solving a problem every time. Like for example, the max recursive step they would give in an exam would be typically less than 10. So you can easily remember for these 4 values, number of recursive steps and return values. But this is not the only nested recursion problem that you can cram and get away with. Most of the teachers are good at coming up with new and tougher problems to stump you. So I will use this as an example to teach you how to tackle any nested recursion problem. Nested recursion is solved using tree with right traversal method. Let's see how we use this method. We start with a2, 1. Since both m and n are non-zero, we reach last else where am-1 means 1, a, m which is 2, n-1 which is 0 is called. Now you cannot solve the outer a unless the nested a20 is solved. So whenever we have to step into nested function, we go right. When we have to solve or step into outer function, we go left. Since we cannot solve the outer function till nested function is resolved, I will go right and step into this function. Since here n is 0, we enter the first else and we get a1, 1. This is not a nested function, so we will go left. We step in and enter last else and we get a0, a10. Again we step right to solve a10 first. Since n is 0, we get a0, 1. This is our base case as m is 0 and it returns n plus 1, which is 2. Now what we do whenever we hit a base case is move up the same number of steps we had come down. So we first return value of a0, 1 which is 2. Next you are returning the value in a nested function. Whenever you return the value to nested function, you put in the values in bracket like how you pass to a function 0, 2. Do not write the function name here, as when you have to count how many times the function is executed, it will be confusing, or use a different color if you wish. Whenever you reach the outer function, means now you are ready to solve it, so you will always solve it on the left side. Since m is equal to 0, we enter our base case and we return n plus 1, which is 2 plus 1 equal to 3. We again step up to a1, 1 and return 3. We step up and now we are again returning the value of nested function, so we will give value in brackets 1, 3. This now means the outer function is ready to be solved, so we move left. With m as 1 and n as 3, we again go to last else and the function called is a0, a1, 2. We need to solve a1, 2 first, so we step right and it gives us a0, a1, 1. Now whenever you are solving any tree kind of question, keep an eye open for functions you have already solved. Like we have a1, 1 to be solved, and I see we have already solved a1, 1 earlier, so you can save some exam time and just copy the same tree below here. Only change is I am going right this time, as a1, 1 is a nested function. We know a1, 1 returns 3, so we substitute that value in the nested function and we get 0, 3. Now we are ready to solve a0, 3, so we move left. Since m is 0, we enter the base case and return n plus 1, which for us is 3 plus 1 equal to 4. We then return this value to outer function a0, 4. We then go left to solve it and it enters base case and returns n plus 1, which is 5. This 5 is then returned back to a1, 3 and then as final answer of a2, 1. A quick count of a in this reveals it has been called 14 times. Do not forget to count all nested functions when doing the counting. Next we will do indirect recursion. Here the question is what is returned when f1, 2, 5 is called. Here we see there is indirect recursion. In both of them we can identify the base case and individually we can see both are tailed recursion. So we will follow the same step or stack call method to solve it. We start with f1, 2, 5. All the statements above the recursive call which are to be executed upfront, we write on the right hand side and we go ahead and execute it. So we print 2. We increment low to 3 and then call f2 with 3, 5. Again we execute the statements above the recursive call and print 3 and increment low to 4. We then call f1 with 4, 5. We continue this till we hit the base case and we return. Since there is no value to return, we already have our answer printed, which is 2, 3, 4, 5. And here f1 is called 3 times and f2 is called 2 times. With this we come to the end of this video. In our next video, we will cover sorting algorithms using recursion. Thank you and goodbye.